Okay, so good morning everyone. My name is Sophie and I work in France at Institut Agro, which is an engineering university in agronomy, and also at IRSTV, which is a CNRS Federation on Urban Environment. And today I will present you our work on a new scaled outdoor facility to study street tree benefits with controlled water availability. So, as we all know, we are in a context of heat stress in summer with the combined effect of global climate change and urban heat island effect. And street trees appear as a promising solution. Indeed, they can provide cooling through transpiration, but also shading. They require a little space on the ground for the tree pits. Of course, the drawback for this is that they have limited access to water, and they can also provide a range of co-benefits. So in the literature, you can find quite a range of studies, and especially experimental studies addressing street tree benefits. Most of them were conducted in situ at scale 1, and you have in these two very good reviews from Jameh and co-worker and Rahman and co-worker. So their studies are very interesting, but they have usually two shortcomings. And the first one is that they often lack of a control zone without trees that is fully comparable to the zone with trees. And the other one is that there are little studies addressing and controlling the soil water stages. The other way to go is to perform reduced scale experiments. So the advantage is that the canonical urban environment, which can be easily reproduced or modelized, and it's also easier to get a control zone, but most reduced scale studies have used like purely mineral streets, and they were focused on air leaks and heat exchange, and there are only few studies on vegetation with reduced scale streets. And also this raises the question about representativity with respect to full-scale in situ experiments. So in our research program, our objective is to quantify and understand street tree benefits as a function of water availability using a scaled outdoor experiment. So here is the street. So it's located in Angers, in France. We have a CFB climate, temperate, oceanic. The street, as you see it here, is north-south oriented. It is 15.6 meter long, 2 meter wide with 2 meter high building, which means the aspect ratio is 1. So we say that we have a reduction factor of 5, considering a full-scale street with 10 meter high buildings. So we have representative urban material with asphalt on the ground and white walls made of concrete and insulated. So at the back of the street over there, you can maybe see a central row of trees. It's ornamental apple trees, and they are inside containers. So let's have a closer look at the streets. So with the top view here and the front view there. So you can see that the street is actually organized into 3 zones. We have 2 vegetated zones here, each one of them with an alignment of 5 trees. The difference between the 2 vegetated zones is the irrigation, because the north zone is always well irrigated, while we sometimes put under water restriction the middle zone. And at the south of the street, you have the 3rd zone here, which is purely mineral and which can be used as a control zone. So for the tree height, obviously it's growing along the season, but we try to maintain them between 1.6 and 2.3 meter high so that it's consistent with our street dimension. We also have measurement outside the street with meteorological mast and a weather by Meteo France weather station. And one originality of this facility is that it's instrumented along the soil-plant atmosphere continuum. And for the microclimate measurement, in fact, we have a measurement plane in each one of the 3 zones, and it's an identical measurement plane that you can see here. And most of the measurements are focused here at 40 centimeters from the ground. So why 40 centimeters from the ground? It's because when you go back to full scale, it's about 2 meters high, which is relevant for human thermal comfort. At this height, we have air temperature measurements, relative humidity, wind with sonic anemometer, and globe temperature measurements. So this enables us to compute the UTCI thermal stress index. We also have two pyranometers for shortwave radiation, one which is below the tree crown and one which is just above the street, which enable us to compute the tree transmission ratio. There are additional measurements that I'm not showing here, including air temperature measurement at other height and also surface temperature measurements. So by comparing the microclimate between the three zones, then we can identify the tree climate benefits and also the impact of a water restriction by comparing the two vegetated zones. So for the soil now. So as I mentioned, our trees are inside containers that you can see here with the front view and the top view, and the containers are placed inside tree pits. So this enables us to control irrigation because we have no water uptake from rainfall because our pits are covered with a lid, and we provide water with 4 drippers per container. We measure the soil water status using a 4 tensiometer per tree for the soil matrix potential and also using 2 TDR sensor for the soil volumetric water content. And as we control irrigation, we measure the soil volumetric water content and we also monitor drainage. This enables us to realize the soil water balance and to compute tree transpiration. So for the results, so I will first give some comments on the representativity of the street and the scale reduction factor because it's a question that is often asked for scale experiments, and that's fair enough. And then I will show you some of the results we have for well-watered trees and water-restricted trees. So for the representativity of the street, as I mentioned, the reduction factor is of 5. So the first point is to ensure geometrical similarity. So that's what we did for the street dimension, the tree dimension, the measurement height, and also the soil volume for the trees, which is reduced by the reduction factor to the power 3. So then we have to look at non-dimensional parameters, especially for the momentum equation, and also we have to make sure that in the energy balance, the respective weight of all the heat flux is conserved. So the energy balance is mainly driven by the net radiation here. And since our facility is outdoor, we have real incident global radiation, we have representative materials with classical thermal properties, and also with this aspect ratio of the street, the shake factor for the radiation exchange are conserved, which means that the net radiation is mostly conserved, and so is the conductive heat flux to the wall and to the ground. So for the flow field, it's a bit more touchy because it's governed by 2 non-dimensional parameters, the Reynolds number and the Richardson number, which in fact are directly impacted by the scale reduction factor. But the Reynolds number and these 2 numbers, of course, are varying a lot depending on the meteorological condition. But I'm just giving here some order of magnitude. So, for instance, based on an incident wind speed of 1 meter per second, the Reynolds number would be very high, which means that we are fully turbulent and independent of Reynolds number. And the Richardson number for a calm and like very sunny day can reach down to -4 for mixed convection. Even though the convective heat flux can be impacted because, of course, we are lower in the atmospheric boundary layer, and we also have a lower Richardson number. So it can have some influence even though the air surface temperature gradient are conserved. And I also want to mention one limitation, which is that the microclimate measurement height at 40 centimeters from the ground, especially in the non-vegetated part of the street, is inside the thermal boundary layer developing on the ground. So air temperature there are slightly impacted. So for tree transpiration and transmission ratio, I give you here the street coverage ratio, the leaf area index, and the usual transpiration cultural coefficient of ornamental apple tree with respect to grass. And if you conserve this number, then the latent heat flux and the radiation transmission ratio will be conserved as well. Of course, all this discussion about the scale reduction factor is if you want to compare with other experiments, or if you ask about the representativity of this facility with respect to full-scale experiment. But if you wish to use such data for model validation, then you just don't care about it, because you do the model at a reduced scale, of course, and you can directly compare to this. So some results about the tree benefits with water availability. So what we did is, for this example, that we chose a sunny and rain-free period in July 2021. And to the left here, you can see the evolution of the soil volumetric water content for 2 trees. In green, you have 1 tree which is inside the well-watered zone at the north of the street. And in red, you have 1 tree which is in the water-restricted zone, so in the middle of the street. And at the beginning, both zones are actually irrigated in the same manner. And from this time here, with the first black line on the 15th of July, we then stop completely irrigation on the water-restricted zone. And you can very clearly see here the volumetric water content, which is decreasing until reaching a point there which is close to the permanent wilting point. And then we turn back on irrigation. And for the trees, which is in the well-watered zone, you can clearly see that it maintains constant volumetric water content close to field capacity. So next, I'm going to show you some microclimate results on the last day of the water restriction here. So you can see, the UTCI evolution as a function of the day here, and in 4 zones of the street: the well-watered zone, the water-restricted zone, the non-vegetated zone, and outside the street. You can clearly see here the shading effect of the wall and the UTCI decrease thanks to the trees, which is about 8 degrees for the well-watered tree, and which is slightly lower here for the water-restricted tree, taking into account the pre-existing difference. The final difference is about 1.2 degrees. The transpiration that you can see here of the tree was reduced by a factor of 5 between the well-watered tree and the water-restricted tree. And the transmission ratio, which was about 9% for the well-watered tree, slightly increased for the water-restricted tree, and this was due to the leaves wilting under restriction. And I will just show the conclusion there. Thank you.
Thank you for the presentation. So we have time for just 1 or 2 questions.
Thanks for your presentation. It's so good to see a scale outdoor experiment with tree, because I also conduct some similar experiment in Guangzhou before, 4 years ago. And actually, I also wrote a paper about this kind of scale outdoor experiment. I'm so excited to see this kind of experiment, and also excited with the result of the radiation and evaluation expiration classification. When I'm reading the paper and also in your presentation, I have one question. Is that if you put your tree in the different sides of the tree canyon, will that affected by this kind of position? For example, the radiation or the wind can have some vortex or the effect of the other side of the tree, and in the middle tree side, the effect maybe is different. So I want to see, do you have any consideration to doing this kind of position placing? Thank you.
Okay, thank you for your question. That's a very good question. So, in fact, it's true that here in the analysis, we consider that the 3 zones are independent and at equivalent position of the street, but of course, this is not fully true. For the wind aspect, in fact, for instance, the data I'm showing here is from wind coming from the northeast, and we analyze this type of graphic for several sunny days with very different wind direction, and it didn't affect the results. The other point also is that we conducted other experiments the following year with a longer water restriction, and then we finalized our data for that. And this summer we took out all the trees to do measurement on the mineral only streets, and to see, depending on if you are at the north, at the middle, or at the south of the street without tree, do you already have some slight difference, or is it purely equivalent? So this will give us some more information about this.
Thank you very much. Sorry, we won't take any more. So the next speaker will be Dr. Mikhail from Moscow.
Thank you. Yes.